Okay, so today video is about the making of an OR gate using NOR gate and from the NOR gate. By the combination of the NOR gate and the NOT gate, we can make an OR gate. Basically, it happens when a person do not have OR gate, or the OR gate that was being present with him has been damaged. For that reason, we can make an OR gate by using by the use of the NOR gate and an AND gate. So for that reason, starting it directly, the NOT gate, basically the IC for the NOT gate is the 7404. You see here the 7404 is being written, just like you see 7404. Okay, this one is the IC for the NOT gate, and this one is the IC 7402 for the NOR gate. By the combination of these two ICs, which is basically they are gates are being present in this. By the combination of the NOR gate and the NOT gate, we will make a OR gate. So for that reason, the wires, voltage source, these two IC and an LED, these are going to be used in this verification. Okay, starting it, this one is the IC for the NOT gate, and this one is the IC for the NOT gate, and this one is the IC for the NOT gate. Okay, so I will place it here. This one is slide cut. We'll place it here. As I've told earlier, there's a slide cut. Basically, it should be placed like this. The slide cut should be like this. And this one is the for the NOT gate. Again, there is a slice cut on this IC, and it should be placed according. The slice cut should be at the top. It should be at the upper side. Okay. Now you see. Both of them are reconnected. You see, I can place this one IC here, and this one, the NOT gate IC could be behind of this one IC. It doesn't matter. Okay, it depends upon us whether I'm gonna use this. I'm gonna place it at here at the top, and this one at the bottom. So it's up to me. So just for the sake, the connections are going to be. It would be a little bit difficult to differentiate the wires. So for that reason, I'm placing this one at the top and this one at the mid of the breadboard. I can place it here and place it here. It doesn't matter. Okay. The first thing that I've told you earlier, then all the ICs, basically this one is the, when it is being connected like this, when the slice cut is the upper side, when the slice cut is being at the upper side, so in that case, this would become, this would be VCC, this would be VCC, and this one would be the ground. So for that reason, the first thing that is going to be you are going to do is connect this one with the positive side. Now in this video, I am considering this one column as the positive side, so I have connected this one with the positive and this one with the negative. This one is being connected with the negative side. Okay, remember, this one is the NOT gate and this one is the NOR gate. Now I will also give the ground and the positive side to the NOR gate IC. So for that reason, I'm connecting this wire also. Now I can do it like this. For example, I will just give it here, this one positive, and place it here. I can do it like this, and also just like this. Okay, by giving this and connecting this, so it means the same. It doesn't matter. Okay, like this and this one, whether I'm going to place this one here or place this one here, so this basically doesn't matter. Okay, it means the same, the meaning is the same. So for example, I'm just doing, okay, like this. Okay, this was being giving the connection to the both of the ICs. Basically, as I've told you earlier, in the NOR gate there are basically 4 ICs, and in the NOT gate there are basically 6 ICs. Input, output, input, output, input, output, input, output, input, output, input, output. So there are basically 6 gates in this IC and 4 gates in this IC. Okay. Now it's up to making about the making of the OR gate from the NOR, from the combination of the NOT gate and the NOR gate. So for the first thing that we are going to do is make the circuit or make the connections for the NOR gate, and after that we will connect this with the NOT gate, and an OR gate would be OR gate would be made. So for that reason, the first thing they're going to be used, as you know, this one basically represents the output, giving it as an output and leaving this wire as it is. Sorry, this one wire like this. Okay, not connecting it anywhere in the breadboard. The next two basically represents the inputs. So for this reason, this one input, connecting it with the negative side, as this was the first condition of the truth table of the NOR gate. And this one, the input B, you see that input B is like here it is, input B connecting again to the negative side. So here input A and input B, both of them are 0 now, okay, which means that both of them are being connected with the negative side of the breadboard. As I've told you in the previous video too, this one is the LED, this one is the positive, the long side is the positive, and the short one is the negative. I am placing it, for example, like this here, in this at the mid in the middle of the both of the ICs. This one is the positive and this one is the negative. This one positive. Okay, placing this wire and connecting it with the positive side of the LED. Okay, and giving the negative or side, connecting it with the negative side, for example here. Okay, now it's being there. You can see the connections. It is being given like, you know how it is being given. So this was all the connection. Now this is the connection that I have given is totally for the NOR gate. Now I have not made an OR gate. First I'm going to verify that whether it is a NOR gate or not. For that reason I'm just going to verify the conditions, and after that, by the combination of the NOT gate and the NOR gate, we will make a OR gate. Okay, so as I have considered this one is the positive, so I'm placing this one wire here. Okay, and this one wire here. You see LED get on, it lighten up, which means which is basically due to the inputs, both of the input are being connected with the negative side of the breadboard. Now you see, as this wire basically represents the negative side, when I place it here with the positive, LED is off. Again this one, just like this, LED is still off, which is verifying that this is the NOR gate. Now okay, as the main thing that I'm going to do is to make a OR gate. So for that purpose I'm just removing again the voltage source. I've removed this one. Okay, and also I'm just going to remove for example, this one was the output of this one was basically the output of the NOR gate. What I will do, I will just connect this output wire in the input of the NOT gate. This one is basically the first gate of the NOT gate. So I will place the output of the NOR gate. I'm again repeating the output of the NOR gate, connecting the output of the NOR gate with the input of the NOT gate. This one is basically the input of the NOT gate. So this one is the input. Now what I've done, I've connected the output of the NOR gate with the input of the NOT gate. The next thing what I will do is connect the output of the NOT gate with the positive side of the LED. You see, this one was the positive side of the LED. Now this is basically an OR gate. You see whether it is an OR gate or not. So for that reason I will just give it a voltage source, as this one is the negative, this one is the positive. Now you see, okay, see it, when it was a NOR gate, when this connection was the NOR gate, these inputs these were basically, when these were connected here, so the LED was off, because according to the truth table of the NOR gate, when the both of the input are connected with 1, which means with the positive side or any of the input is 1, so the LED would be off. But according to the truth table of the OR gate, when both of the input are 1 or any of the input is 1, so the LED would be on. So these were, which is basically input A and input B, are being connected with the positive side, or which means that both of the input are 1, so the LED is on, which means the output is 1. So it is verifying the fourth condition, basically it's verifying the fourth condition of the truth table of the OR gate. Now for the other condition, that whether it is OR gate or not, so for that purpose, you know, see, I'm just removing this one. LED is turned on because the current is flowing across these through these ICs. Okay, now this you see, this one is the negative. You see, input A is now 0, input B is now 1, but still LED is off. LED is on, which is verifying the second condition of the truth table. Now you see, this one input A, I'm placing it here, and input B is 0, which means it's being connected with the negative side. So what I did, this one input is basically now 0, and this one input is 1, and still LED is on, which is verifying the third condition of the truth table of the OR gate. Now when both of the input are 0, so what will happen? You will see that, you see, LED gets off. So which is basically the first condition of the truth table of the OR gate, according to which when the both of the input are 0, so the LED would be off. So this was basically the making of the OR gate from the combination of the NOR gate and the NOR gate. Okay, as I've told you earlier, that basically there are 6 gates in this IC and 4 gates in this IC. So for that reason, I will use the other gates too. So and accordingly, it will get easier for use there. For example, one can use this one gate, this one gate, this one gate, this one gate, this one gate. I'm using directly the other gate. For example, this one is the second number gate, so I'm going to use the second number gate. For that purpose, I'm just removing the voltage sources again. This one was the output, and this one was basically represent the first gate. You see, this one here, this one is the first, this input A and input B. Now this one was the first gate. Now I'm using the second gate, and the second, this is in the third row. Basically this is the input, which is basically the output of the NOR gate, basically. Yes, and this will be connected with the output. Now you see, okay, like this more clearly, like you see here, or like, yeah, like this. This one, you see, this one was the output of the NOR gate, which basically came here from this one, and I've connected this with the negative, the second gate. I'm using the second gate of the NOT IC. You see, this one is, so I'm connecting this the output of the NOR gate with the input of the NOT gate, and this one output connecting with the LED. It is already been connected. Now you see, when I give the voltage source like this and like this, LED is still off. Now you see, LED get on. One input is input is 1 and other is 0, which is the one of the condition of the truth table of the OR gate. You see, and both of the input is 1, still LED is on, which is basically one of the condition of the truth table of the OR gate. So basically this is basically the connections that are going that will be made for the verification of the truth table of the OR gate. You can see this connection more clearly or more precisely. I'm just removing or like this. Okay, you see, okay, sorry, as it is being removed. 1 second. Okay, again it lighted up. Okay, more precisely, you see, this is the whole connection. So this was totally about the making of the OR gate from the combination of the NOR gate and the NOR gate. Moreover, as I've told you earlier, basically there are 6 gates in this IC of the NOT IC, and here are 4 gates. So it depends upon, for example, you can use this one gate, this one gate, this one gate, this one gate. The thing that are going to be changed, you will just change the connection. For example, this one would be 1 second. Okay, this one is basically the 4th gate. So in this one, this one is the input B, input A, and this one is the output. The 3rd gate is this one, input B, input A, and this one is the output. So the connection should be given accordingly. This one again, this one is the NOT gate, NOT IC, and this is basically 6 gate. For example, if I'm going to use this one gate, so for that reason this one would be output and this one would be input, and the output of the NOR gate would be connected with this, the input of the NOT gate, and this one output would be connected with the positive side of the LED, and accordingly the OR gate would be made. So this was all about the making of the OR gate from the combination of the NOR gate and the NOR gate. So thank you for watching. Please do subscribe my channel. Thank you.